In this lesson, we're going to talk about measures of the center of the data. Now, when we talk about measures of center, what we mean is a value that describes the data by summing it up in one value. So it's a way for us to give a representative or a typical value in the data set. Now, there are three commonly used measures of center. We have the mean, median, and mode. The mean is the average that we're probably the most familiar with, which is where you add up all the data values and then you divide by the number of values that you have in the set. And the notation for this will either look like this if it's a sample mean, or it will look like this, which is kind of like a cursive M, and that would be for the population mean. And the way that you pronounce that M, I'll put it in quotations here, it's pronounced mu. Now, you might see more notation on how you actually calculate the mean. If you see this symbol, this is sigma, and that is just a symbol for sum, which means add up all the values. So you might see the mean described using an equation, which will look like this. You'll have the sum, and then it might look something like this, where xi represents all the data values, and then you divide by n, which is the number of data values. So this is just a fancy formula for saying the same thing that I said up here in words. This means add up all the data values, and then this means divide by the number of values you have in your set. Now, the median is another way to measure the center, and this is something that we've already talked about as well. The median is the 50th percentile, or another way to say that is Q2, the second quartile. And that is the value that when you list your data set in increasing order from smallest to largest, it's going to be the middle value. And that's going to cut the data in half. So there will be 50% of the data on the right of the value and 50% of the data will be on the left of that data value. And that, again, only works if the data is in order from left to right. Now, one value that we have not talked about yet is the mode, and you've probably heard of this before, but let's do a quick refresher. The mode is the value in the data set that occurs the most, or you can say the most frequently. Now, there are special cases where you would have no mode, or you can have more than one mode. Let's go through a couple quick examples. So, if I gave you a data set that looked like this, in this case, the mode would be 3, because that is the data value that occurs the most. In this next example, let's say I give you this. All of the data values are written the same number of times. So we don't have any one data value that repeats more than another data value in the set. So this is a special case where we would say we have no mode. And then the last special case is when you can have more than one mode. So let's say I gave you this data set. So I have all of this listed out. I see that 1 and 4 both occur a lot compared to the other data values, but they both occur the same number of times. So in this case, I would say we have 2 modes. We would have 1 and 4. Usually you get this case where you have 1 mode, but these are special cases that can happen. Okay, let's go through our first example here. It says, AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug are as follows. And it's listed it here for us from smallest to largest, which is nice. And we have to calculate the mean and the median. So the mean would be if I take all of those data values, so I'll label these are my XIs, and I add them up, and then I divide by the number of values that we have, which in this case is 40. I'll let you guys do that on your own. I'm not going to waste time doing that in the video, but I'm sure you can add up all those values. It just takes a little bit of time. When you add all of those up and you divide by 40, you should get 23.6. All right, now for the median, since we have 40 data values, our N is 40. Since we're looking for the median, that's our 50th percentile, so my K is going to be 50. And I'm going to use our formula for finding percentiles. So I'm going to take 50 over 100, and I'm going to multiply it by 41. And I'm multiplying it by 41 because if you remember in our formula, in the previous section, what goes in those parentheses is n plus 1. And in this case, our n is 40, so I'm going to add 1. So when I find this value, I'm going to get 20.5, which means I need to take the average of the 20th and the 21st position. So when I count from smallest to largest up, and I find the 20th and the 21st position, that is going to be, let's write this down, in the 20th position, that's going to be 24, and then the 21st position is also 24. So when I find the average, I have 24 plus 24 divided by 2, and that's going to give me 24. So this is going to be our median. Now let's practice finding this on the calculator to check our work. Okay, let's go ahead and work through finding the mean and the median on your calculator. Now, when you have a large data set, it's definitely easier to do it on the calculator. But if you have a smaller data set, by the time you enter everything in, it's probably easier to just do it by hand. But it doesn't matter to me which way you do it. I'm showing you both ways so that you can choose which way you want to do it. So you want to first hit the Stat button and go to your Edit option so you can edit your data list. Choose a list. It doesn't matter which one. Pick one and enter your data values. Just make sure you pay attention to which list you're putting the data values in so you can tell the calculator the correct list later. So go ahead and pause the video, put your values in, and then unpause. Once you have your data values in there, what you want to do is you want to hit the Stat button again. But this time you want to arrow over to Calculate, the same place where you go to get your 5-number summary. You want to access option number 1, one variable stacks, hit Enter. Tell the calculator which list you want to perform the one variable stacks with. So I have my data values in list 1, so I want to make sure this says list 1. And then I'm going to tell the calculator to calculate. I'm going to hit Enter. And then it's going to give me a whole bunch of values here. Now we've done this before with 5-number summary, and the 5-number summary is down here, right underneath where your n is. N equals 40, that tells me how many data values I have. And then here's my 5-number summary. If you remember, the median is one of the values in your 5-number summary. So here's our median here, 24, and that's what we got when we calculated it by hand. Now to find your mean, that's actually the top value right here. That's your X bar. And when we did it by hand, we got 23.6. The calculator got 23.575, but I rounded to 1 decimal place. This value here, where it has the sum of the x's, this is where the calculator adds up all of your data values in your list. So if you take 943, which is the sum of all those data values, and you divide by 40, that's where the calculator is coming up with the 23.575. So in the next example, we're going to talk about how one average better describes a data set than another, and it's better sometimes to use one value over another. When we use the word mean, sometimes that's used interchangeably with the word average, but what is important to understand that the mean is a kind of average, and so is the median, and so is the mode. The word average describes, in general, the measures that you can use to describe the center of the data. When we talk about a specific kind of average, that's when you use the word mean, median, or mode, because that describes how that average is calculated. So mean, median, and mode all fall under that umbrella of average. So it's not necessarily always the right thing to do to use the word mean interchangeably with the word average. So there are times when using one of those values over another gives us a better understanding of the data. And this example is one of those times. So in this example, what we want to do is we would rather use the median in this case rather than the mean, because in this example, it talks about a town. It's a small town, 50 people. One person earns, in the whole town, one person earns $5 million. So this guy has this awesome job. He's making lots of money. But the other 49 people each earn about $30,000. So when we want to use an average to describe the salary of the people in that town, if I use the mean, that means I would add up all of the data values and divide by 50, since there's 50 people. Well, there's 49 of the 30,000s, so I would add 30,000 49 times. And then I would add in the 5 million. When I find that average, I'm going to get 129,400 for their yearly salary. Because that 5 million is thrown in there, it's throwing the mean way off. If I look at the median, which is that center value, when we order it from smallest to largest, we're going to get 30,000, right? Because we're going to have 30,000, 30,000, 30,000, 49 times in a row. And then at the very end, we add on that 5 million. That's the highest value. So the middle value is going to be 30,000. Now of these two values, this 30,000 does a better job of describing the overall salary in this town. So this is one of those cases where it's better to use the median to describe the data than the mean. So keep that in mind as we are going through the course, that sometimes one is better to use over the other. Okay, now for this example, we're going to find the mode. There really isn't a way to find the mode on the calculator where the calculator just gives you what the mode value is. However, the calculator can help you find the mode if you have a large data set. If you have a very large data set, I would suggest that you put your values into your list and sort them from smallest to largest, because once they're sorted, it's easy to spot which value appears the most. If you have a smaller data set, then usually it's easier to just eyeball it. Like in this case, the data set is small enough that when I look at it, I can see that 72 occurs 5 times here. I don't see any other data value that occurs more than 5 times. So this one is easy to just eyeball it. So I would say in this case, the mode is 72. So looking at this next example, we have a frequency chart here with statistic test grades, and we have our grade intervals here on the left and then the frequency on the right where it's listed as number of students. Now, if I wanted to find the mean of this class using the information in the chart, it's impossible to find the exact mean because the data values are grouped in these intervals and we don't know what the individual grades are. I just know that there's one grade that falls between 50 and 56.5. I know that there are 4 grades that fall between 62.5 and 68.5. So it's impossible, since we don't have those individual data values, to find the exact mean. So we're going to use a process that we can estimate the mean, and we're going to do that by finding the midpoints. So let me organize this here real quick. And we talked about how to find a midpoint in a previous section, but just a quick refresher. If you forget how to do that, you take and add the lower bound, you add the upper bound, and then you divide by 2. That will give you the midpoint. So in this first interval, my lower bound is 50, my upper bound is 56.5. I'm going to add those together and divide by 2, and I'm going to get that the midpoint is 53.25. And then I'm just going to do that for each of these intervals. On the second interval, I'm going to get 59.5. On the third interval, I'm going to get 65.5, then 71.5, 77.5, 83.5, 89.5, and then 95.5. So these are all my midpoints. Then what we're going to do, actually, I need to erase this so I have more room. Let me put that somewhere else. I'll put it over here. The midpoint is the upper plus the lower divided by 2. Okay, now what we're going to do is we're going to take each of these midpoints and multiply by the frequency, because I know that I'm going to have one number that's around 53.25. I want to make sure when I take my mean that I add in a 53.25. So I'm going to take 53.25 times 1. That gives me 53.25. So I'm going to take, in this column, this is my midpoint times my frequency. All right, now I'm going to take my number of students in the second class and multiply by 59.5. Well, there's no grades on that interval, so this is just going to be 0. For the next interval, I know I have 4 grades that are around 65.5, so I'm going to find out what that is. So I'm going to take 65.5 times 4. That's going to give me 262. Then in the next class, I have 4 grades that are around 71.5. That's going to give me a total of 286. I know I have 2 grades that are around 77.5. So that's going to give me 155. I have 3 grades that are around 83.5. So that's going to give me 250.5. I have 4 grades that are around 89.5. That's going to give me 358. And then lastly, I have 1 grade that is around 95.5. So I'm going to take 95.5, multiply by 1, Okay, now that I've taken all the midpoints times the frequencies, now I'm going to add this up. When you add that up, you should get 1,460.25. Now the last step is you want to divide by the number of values that you have. I had one value here, 4 here, 4 here, 2, 3, 4, and then 1. That gives me a total of 19. So I'm going to take 1460.25 and divide by 19. And that's going to give me my estimated average, which is going to be 76.86. So we use the midpoints of these intervals to estimate the scores in each interval. And then we just took the average as we normally would. So keep in mind, again, this is just an estimate since we don't know the exact values that are on these intervals. Okay, last example is about the weighted mean, which is very similar to what we just did. So when we talk about a weighted mean, it's a kind of average that instead of each data point contributing equally to the mean, each of those data points contribute different values or different weights than others. So when all the weights are equal, if all the points contribute an equal weight, then that's just the regular mean that we always use. And sometimes it's even called the arithmetic mean. But when some points are worth more than others and they have different weights, that's called the weighted mean. And here's our fancy formula for that. And all this means is all your x values represent your data values. So x1 is the first data value, x2 is the second data value, etc. And then the w's are the corresponding weights. So when you see w1 or w2, w1 is the weight for the point x1, w2 is the weight for x2, etc. So then you add up all of those products and then you divide by the total weight. And remember, that's what that symbol means, is we're going to add them all up. So this is saying we're going to multiply each weight times each value of x and add it up. And then we're going to divide by the sum of all the weights. That's what those fancy symbols mean. Okay, so let's walk through an example. A perfect example of somewhere you would see a weighted average is when you compute your GPA. When you take a 5 credit hour course, that's going to be weighted in your GPA heavier than if you take a 1 credit hour course. Each of those grades that you get for those classes, since you have different credit hours in each of those classes, they're not contributing equally to the average. So let me write this down. So my x's, I'm going to make a chart here. My x's are my data values, are my grades, 3.7, 1.9, 2.8, and 3.3. The corresponding weights would be 5, 3, 5, 5. So what we need to do then is find the products. So we're going to multiply each of the weights times the corresponding x value. And then we're going to total them up and divide by the total number of credit hours, which is what your weights are. All right, so when I take 3.7 times 5, that's going to give me 18.5. When I take 1.9 times 3, that's going to give me 5.7. When I take 2.8 times 5, that's going to give me 14. And when I take 3.3 times 5, that's going to give me 16.5. All right, now I am going to add up all those values. So I'm looking at the total of my WX's, which can be written like this. I'm going to add up the sum of all my WX's. When I add those all up, I get 54.7. When I add up all my weights, those are my credit hours, all my W's, I get 18. So to find the GPA, I'm going to take the sum of all my products, which we said is 54.7, and I'm going to divide by the sum of my W's, which is 18. When I do that, and it says to round to 2 decimal places, when you do that, you get 3.0388. And then when we round to 2 decimal places, that gives me 3.04. So there's the GPA calculated for this semester with these grades. So looking ahead to the next section, we're going to use our understanding of the measures of center to start talking about the shapes of different data sets.